Hey YouTube, how is it going? I hope all is way. All is way. All is well. I hope all is well. Today, our drink of choice is Red Bull because it gives you wings. Sponsorship. Give me sponsorship. I'm open to certain types of sponsorships. There's some that I won't accept, but when it comes to beverages of any type, I'm open to a conversation. Just FYI. Anyway, so today we are going to make the layout of our nice, 5E3 style amplifier, our new build series that we're starting and that we have created a schematic for the other day. Now, if you have not watched that video, please do, because it does kind of get you down the road on how to do this. If you're new to this channel, do know that we are trying to learn about how to build guitar amplifiers. It is mostly biased towards beginners and intermediates. I'm not trying to inundate you with all the math side of things, running load lines, and all the deep kind of stuff that, some of the actual guys do this stuff. They probably laugh at me a little bit, thinking I'm just kind of goofy or whatnot. But I'm really just trying to get the rudimentary aspect of it down so you can understand. And if you can understand it enough, that'll get you to the point, I hope, where you feel confident to open up an amp that you already have, or to go out, buy a kit, or acquire parts to build an amp of your choice. That is the idea. That is the concept here. We're trying to take some of the fear out of doing it and just giving you those stepping stones to kind of get there. All the deep stuff really doesn't matter. There's so many blueprints kind of in the world at our fingertips that you can take. And if you do anything that's just kind of up the middle, you're gonna create something that will work. Now, whether you'll like it or not, that's up for debate. But chances are pretty good if you stick pretty close into that lane, it's gonna be okay. It's gonna work. But with this, this channel here, the hope is that there's not too many videos that kind of talk about nothing. So it's kind of easy to find. I'm going to start putting these things into little buckets here soon to kind of, make it a little easier to sort through what is what. But, this series here is the objective of this particular one was twofold. One was to show you literally how to do it in real time and kind of just enforce some of the things that we've already talked about prior. So in this particular video, it's hopefully not going to be too long. I'm not going to go super crazy, but this is where your personality is going to show in this amplifier build. Mainly because it is an art. You don't have to have necessarily a lot of understanding about it, but you do have to understand a few rules. So there are some rules to this, and those rules are pretty basic. For the most part, you want to keep, all your stuff as separated as you can, right? So you're trying to keep things so they're not touching each other, they're not, crisscrossing over the top of each other. You're trying to keep things in their own lane and as separated as you can. Number two, you're trying to reduce the wire length and the length of any given run throughout the amp, right? So you've only got like 6.5 inches to 8 inches of depth inside of your chassis. We're really trying to make it so you're not running a wire from this end of the chassis all the way around to this other end over here, right? You don't want your things from your output section getting near your input section, right? So we're trying to reduce and keep the length of any signal path as short as we practically can. And short as practical means just that. And then the third rule is that we want to try to minimize, signal wires laying not so much atop of each other, and at 90-degree angles, but we want to try to keep the angle in which they intersect with each other as obtuse as we can, which is to say we don't want them laying next to each other at this nice acute angle. We want them to be pretty much at 90-degree angles if we can get away with it, but obtuse angles objectively. And all that is that we also want to have space, right? So you can look down at something like this and go, okay, they're crisscrossing, that's cool, but then we also want that space in there. We don't want them laying on top of each other. We're trying to minimize that kind of stuff. So those are the three basic rules. Now, what are we going to do that with? Let's go over here and check that out. Never mind the music. It is there for purposes. All right, so get yourself DIY Layout Creator. They just did a recent update, and it did improve some things. It was kind of maddening there for a minute trying to use this software. And they've since kind of fixed some of the little quirks, but then they've added some other ones. It is free. I do appreciate that it is free, so I'm not going to bash on it too much. This is, so far, as best I can tell, the best software for doing this that I can find readily available that is for free. There are others out there, and there are better ones out there, but this one works pretty well for what we're trying to do. When you first open it up, it's going to look like this, and they have this AI thing here. I have not had any luck getting an account that I could work with it. You can create one. I've created several, and it just seems like every time I go to log in, I get two answers: no internet and no account. I'm pretty sure I got internet, so I don't know exactly how that is working yet. Maybe it's just a glitch or something. I don't know. If you want to turn that off, and you're going to want to because you want this real estate back, go to config and then turn off that, show AI configurator or whatever the heck it was. So that'll open up the space. Next thing you're going to notice, I already changed it over here, but when you first open it, everything's going to be in metric or in centimeters. So go ahead and turn that to inches if you're into inches. If you want to keep it metric, that's cool too. I'm an American, so I do things in the imperial, and therefore I like the ye old American system. Sippy time. All right, so the next thing you're gonna want to do is go down here to the zoom. You'll never really be able to work in 100% unless you're really trying to hone in on one particular part. I'd say go straight to 66 or even 50%. I'm going to say start at 50%. That way you can at least see your whole canvas. Now, we need to edit this so we can actually create the canvas that we want to work with. How do you do that? Right-click on, click into the thing, and then right-click on the canvas and go to Edit Project Settings. And here you're going to see everything is in centimeters. You can name it. You can see who the author is. Yes, my name is Luke, etc., etc. And you can pick whatever metric you want in here. So I'm going to go with inches all the way around. I reset some of this stuff, by the way. So now we need to select a width and a height. So I say make it easier on yourself. Just do it the size of your chassis. And most chassis are... most chassis are 17 by something, right? Mine just happens to be 6.5. Now, if you want this to be something that is the same every time, click this button here, and every time you create a new project, it will come out with those dimensions there. Now, for the grid spacing, I suggest researching what turret board you're going to use, and then figuring out what that grid spacing is and go with that. I'm going to go with 375, which is 3/8 of an inch, and that's the grid spacing that I'm using for the turret board that I have. So I will enter that in. Now, if you're going to go with the inch system or the American, whatever you want to call it, the imperial way, you're going to have to learn how to convert fractional into decimal. So if you're interested in what 1/4 of an inch is, you need to know that it's 0.250. If you're interested in what 1/8 of an inch is, it's 0.125, etc., right? And if it is 1/16 of an inch, it's 0.0625. You get what I'm saying? So you got to know how to convert these things down. So there's that. All right, you do that, and you're going to see that things change a little bit here. That's great, because this is what we're now looking at, a 17-inch by 6.5-inch thing, and you can see here that they put the 0 right here for you. And this is scaled appropriately, so you pretty much can trust it that if when you print this thing out later on from a PDF, it will come out at the actual size in which it is meant to be. My luck with it so far has been really good in that regard. So you can get a real good idea of where everything's going to sit, is what I'm saying. Now, over here, favorites. You're probably not going to have favorites made already, so you're going to have to do this. I've already gone ahead and done this. How do you do that? Well, this one is not quite as complicated as it is in Scheme It, but basically just go down the list and find what you're looking for. I prefer using this one, but you can also use this Marshall-style perf board if you want, or you can do it with an eyelet board. I just find it easier to take a blink board and put it out there and just do it that way. It's just there's less imagery to deal with things. So you select it, and then you right-click on it, and you can see remove from favorites, or if you don't have it there already, if you select it and right-click on it, you can see add to favorites. We don't want to do that, so that's not what we're going to do. But you basically just go through each of these little menu items here and select the things that you want. And these items here are really all you need in order to build the whole of the amp. I don't really go too deep. I'm more interested in the layout of the turret board than anything. And then, of course, where the placement of the parts and stuff are going to be. And it gives me an idea of where I need to place the board and where I can place the parts on it to try to align with my tube sockets, etc., etc. The tube sockets are pretty helpful. There are all kinds of options here you'll see. If you right-click it, it'll give you these options here, and you just pick the one that is most appropriate for what you're doing. All right. And then, of course, I selected that. Let's undo that real quick. All right. So for me, there's really no like definitive way to start out. I guess it would be kind of easy. I usually start with the turret board and get it kind of where I want, but I guess it's probably most practical to start with your input and then go from there. Now, another thing that will not be turned on when you get this is this continuous mode. So continuous creation, excuse me. If you turn this on, it will make it so that every time you lay a part out, it will have the next part ready to lay out with it. And I'll show you what I mean by that. So if I click a resistor here and drag it out, it is now blank and there's nothing left for me to click out. All right. But now if I click that and then go back and click the resistor again, I can lay them out just kind of at will, right? So every time I click, I'm going to get a new part that it wants to lay out. You have to use escape to get out of that. And then I'm just going to Control Z my way back a little bit here. There we go. And bloop, there we go. So same kind of principles really as Scheme It. If you select the part, you'll kind of see it turns red, and then Alt, right, left, up, and down kind of do a lot of the different things. So in this case, if you do Alt, up, it's going to take it to the top of your thing, and we'll expose that a little bit more in a bit. And if you do Alt down, it'll send it down in the layers. It's more like a layering sort of thing. I guess since we're going to do these parts first, it would probably be wise to do it in a more normal grid sizing. So I'm going to switch this over to 0.5 of an inch. Okay. And you can see here now we can, it makes more sense, right? So another thing that's going to be important and proper to use would be this this button right here. So this is snap to grid. This is snap to component, and that'll make a little more sense in a bit. And then this is freeform right here. So freeform means you can put it wherever you want, and that's where it'll go. It won't snap to anything. At first, most of the time, you're going to be doing these, snap to grid sort of things. So I'm going to get this out. I'm going to undo that. Then I'm going to do this, rotate it, and I'm going to put it where I want. And you can see it's got an idea for where it thinks the center is, and the center that it thinks it is right here along this edge. That's not where I want it, but so I'm shooting for 1.5 inches, so I need the center of this thing to line up right here. So what I'm going to do is, now that I have it selected, I'm going to take it into freeform mode, and I'm going to put it where I want it so it's centered where I want it. And then I'll do something like that, okay? So that makes sense. I hope it does. All right, so next let's lay out some potentiometers. Now I'm going to put one out, and I'm going to stop there, and I'll show you why in a minute, or in a second, I should say. So I'm going to select it. I'm going to rotate it the direction I want. I like my things kind of pointing up at me. You have to remember we're looking down from the top, or from the bottom. We're looking down at the bottom of the amp. So imagine you turned it upside down, right, the amplifier chassis, and we're looking inside where all the guts would be. So you got to also imagine that if you flip this back around the other way, this would actually be pointing down, and these, of course, would be over here. So my inputs go over here on my amp builds. If you want yours over here, then you'd have to obviously reverse the orientation. I go this direction. So that's me. Okay, you'll notice here, this is what it thinks is the center of this thing. That's not what I want. I want 1.5 inch spacing, so I want the center of this guy to line up on the one that this thing is currently on. So I'm going to select it, go into freeform, and I'm going to move it to right, that's pretty close right there. That's good enough. I'm going to go back to snap, and then we're going to go, make sure it's still selected, and we're going to hit Control C and then Control V. And it will snap to grid much, much easier. So we'll put another Control V out there, and you can see here that it just makes so much more easy job for you. Makes so much more easy job for you. That sounded so proper. Anyway. All right, I'm trying to keep moving, so I apologize. All right, so we kind of got that going on for us, right? Now let's go ahead and get some tube sockets out. So I'm going to right-click that, and I'm going to want this 12AX7 one here. I don't know exactly where I want it yet, but I'm going to say that 1.5 inches is probably a good starting point. I think the other one's going to end up somewhere in, right there is fine for now. So this is the 5E3, and I'm doing this from memory. I'm going to try to do this all from memory, and I'm going to show you a way to do it that might be easier for you, and I'll go back and show you how I have it at the moment. I'm going to tell you right now that this process is going to take you probably a few days, if not longer. Once you do it more and more, it gets a little bit easier and easier. But if you're trying to get clever, every time you come back to it, you're going to see something that you missed, and you're going to be like, ooh, let's try it like that. And it'll take you a while to kind of go back and decide exactly how it is that you want to do this. All right, so we've got a couple things out here. Let's go ahead and put this back to our 3/8 of an inch. So I'm going to go 375 for our grid spacing again here. Hit OK. And then let's go ahead and get a turret board out. And unfortunately, I don't get to show you, but I will show you. I already set some standards for this thing. I need to escape, please. Thank you. All right, so if you select the board and then you drag it out, it's going to be not this size. It's going to be something smaller, and it's probably going to be in centimeters. I made it already so it's 1 inch, and I already gave it an explicit length and width, and I hit these buttons over here. So remember, if you click on these buttons, every time you go to make that part, that's how it's going to come out. All right? It doesn't show you every time, but once you do it once, that's how it retains it. Now, another thing that it's not going to be in is explicit dimensions. When you first open it, it's going to be in opposing points, and you're going to have a hell of a time trying to get this box to do what you want to do unless you change that from explicit dimension, or from opposing points, to explicit dimensions. And then go ahead and put the size in there. You can name it if you want, but I usually just deal with those 3 things. And then click the thing, because most of the time you're messing with the same turret board every time, and you're only putting 1, maybe 2 out there. So just do that, hit OK, and there's your board. Now, as far as the grid spacing goes on it, I find it generally easiest to put it in this mode here. And then, of course, you need to split the difference on things, because it's always going to try to align it to the grid. So we don't want it to align to the grid, so we're going to somewhat soft set it, and I probably needed to make it a little bit bigger than 1 1/4 inches, but whatever, or 10 1/4 inches, but so you can kind of see here, we're just trying to split the grid a little bit, so that way when we lay out the turrets, they kind of lay where we want them to. And these might need to go down one. I didn't think about their vertical orientation, but that's not important right now. We can deal with that in a minute. All right, so now we got the board out. So I'm going to show you a way to do this that might be easiest for you to get an idea of what I was talking about with keeping things from crissy-crossing and getting weird. All right? So what we're going to do is we're not going to use the whole turret board. First, I'm going to go snap to grid and get out of that. And then we're going to come back. Thank you. So now you can see it snaps to the grid. So we are going to use, I'm pretty certain most everything will fit in this grid size here. No, that is incorrect. I need 1 more width here than that. So I'm going to do it like this along this edge here. And I'm just going to do it kind of like Vox style or high watt style, where there's a turret for every, whatever on there. And we're just going to go like this. And you can see that my list over there on the right is populating. That will help out a little bit later. I better undo that. You can double stack these, and it'll get weird later on, and I'll show you why later on. But let's drag some stuff out here. There we go. All right, escape. That'll clear that. All right, don't worry about this right now. That's just there for kind of looks at the moment. So let's go ahead and start laying out some parts. And I find that the easiest way to do this is to kind of just start from the beginning. Start from the beginning of your schematic. We know that we have an input. So let's build the input. If I can say it proper like. So this resistor here, I'm going to drag it, and it's in the wrong mode. There we go, component. And you can see if we put it on component mode, it'll snap to the component that is nearest to it without any issue, but when you're not near a component that has a snappable point, it'll follow your cursor around. So we're going to go from here to there. Oh no, our space isn't big enough. How do we deal with this? You kind of saw how we did it earlier. So we need to select that part by escaping out. So we're going to highlight that part, right click on it, edit selection, and then we need to give it a length. I'm going to put 0.25 for now. I just want it to fit. I'm not worried about the actual size, but the size of the components will be important in a bit, and I will show you that here in a bit. So let's do that. Now it fits like we want it to. Let's create a couple jumpers, and I'm pretty certain that this is going to bounce to the bottom, and it did. All right, so remember I was talking about Alt up and Alt down, how it will move the part through the layer. So I'm going to press Alt. I've selected the jack here. I'm going to hold Alt and press down, and it's going to ask me if I want to. I'm going to say, yes, I do. And now my jumper wire that I put there is back on the top layer. So all it did was send this to the bottom of the layers. So that will become important as well later on. All right, I'm going to try to keep moving. I'm going to try to continue to be somewhat engaging, but just bear with me. This is not a fun and easy process, so just deal with it. All right, so from here, we know that we're going to have signal that goes to our tube. So let's just take a hookup wire, and we're going to bop it to our point there, and let's just get it to our point at the moment. So we know that that's going to go to our second pin, or second, it's pin number 2 on the tube socket, but that's our grid of the first stage, right? Now you can clock this how you want. I usually go in this orientation here. You can go with any orientation that you want. You're gonna have to pick one. This is the way I usually do it, so I'm not gonna bother changing them, but you can rotate these. Again, Alt right or Alt left will rotate those. So now we've got our input, and on this particular build here, I'm doing a bunch of jumpers, if you will. So it's kind of a pain in the butt the first time around. It never seems to work the way you want it to. And as you can see, it's on the bottom, of course. But I'm just going to do this and get it over with. So I know that our grid, there goes the cathode, and then we got anode to, if you wouldn't mind, anode. This might be a point where you want to actually zoom in a little bit. It might make it a little bit easier for you. But for now, I'm just going to select that, hit Alt down, and say yes, enter. And now all my parts are up at the top. And I'm going to go ahead and zoom in at least one so I can get in here and do this a little bit easier. So that one is correct, but this one is wrong. And this is where you have to have like ninja skills, because it doesn't always work right. So you can put it on top of that part all day long and it might not necessarily select it. And I'm going to say that is close enough for what we got going on. So this is how I do my first stage. Obviously, these things here are just jumping all the things together, and that's what allows me to have my parallel triode thing going on. Make sense? All right, so let's start laying out some other stuff. And I'm going to do everything linearly. So it's going to be literally 1 to 1 here. So I'm not going to stack something on top of the other. I'm going to undo that. You kind of see how it's crooked right now. So even when it's on components mode, it doesn't always hit right in the middle. I don't know why. It's one of those little quirks. So when you're going to start snapping out components like those, resistors and capacitors and stuff, put it into grid snap mode and it will be a lot more square. And you'll see right now what I mean. It snaps to the grid much better than it does to components. So we've got our bypass cap here for our first stage. This is our bias resistor for the first stage. So this is our cathode connection here. And then we're going to have a couple of these guys here. So these are our anodes. So this is going to be our plate stage. And then I'm going to put out our plate resistor. So this is our plate resistor here. And I'm then going to go ahead and put out our stage gain stuff. I'm going to skip a hole here, and you'll see why in just a moment. All right, I'm going to stop right here. This is our first stage. And you can see I just did everything linearly. How does all this connect together, you ask? Well, let's go over that right now. So I'm going to escape out of this so I don't have anything. Let's size this first. And I'm going to tell you right now, before you try and go and make your layout, be sure to have all the parts you're going to use ahead of time. Or make sure you do good homework and go to the site where you're buying all these things and make sure that the dimensions, if you can find the dimensions of the actual part, are accurate. It will help you a lot, and here's why. So I'm going to select this capacitor here. This is going to be our decoupling cap for this stage. So we're going to go to Edit Selection, and you can see we have a length and a width that we can adjust. I know that its length is 1.49 inches. And I know that its width is about 0.75, but I'm going to put 0.73 because I think that's what it actually is. And that's for this particular capacitor here. And you can see that it fits within our little zone that we have here. But if I were to move it over one, you wouldn't be able to fit this guy next to it, right? So that's what you got to do for that. And you can already probably start to see how this is a problem in running it like this. You end up having to stretch your turret board out very, very far. But let's start doing some jumpers here. And it'll start making a little bit more sense what's going on, all right? So I've already done the jumpers and I've already set them up. When you get them, they're going to come out like this blue color. I've already set it up so they're black, so just know that. All right, so we're going to jump from here to there. Excuse me, incorrect. Because this is our plate resistor, we need to jump across our board to get into that resistor, which will then jump to here, and then that will jump to there. These two need to tie together on both ends. Okay, so this is our cathode. Remember, this is our bypass cap, and this is our bias resistor on the cathode. And then these two here are my sailover. This is part of my coupling capacitor network, and then my base cut, knob. But you can already see kind of one of my no-nos here. I like keeping all the high voltage stuff on its side of the board, which I call its side of the board the stuff that's furthest away from the input. Now, in this case here, this is how you would have to do it. And imagine that these connections are underneath the board. You will not see these on the top, although you could do it on the top if you wanted. All right, so we've gotten that. Now let's do some other connections here, just for the S's and the G's. So we need to go from here somewhere and here somewhere, and then go into our, we got to go into this mode. So we want to go into the anode. And let's get this. So you got some Bezier curves that you can create, and these you get 2 points, and the 2 points are often enough to get you what you need. You can make goofy things like that. It's not how the wire is actually going to lay out, but it gives you a good idea. And then that goes to our cathode. Oh, don't miss things, by the way. If you miss, you'll know, because things get really weird really quick. I do not think that this is going to be this close, but for now we're just going to leave it like that. We'll probably pull them down here in a minute. All right, so that's our first stage. We're done. Almost. We're almost done. Let me do this. So there's our ground, right? So we need that to go there. And I'm going to just kind of do this one at a time instead of just laying them all out. So this would go to there. All right, there's that one. And then we need a couple more to go to our thing. There we go. And this is actually showing out how it would be wired appropriately. That would go there. And this one will go click there like that. All right, there you go. There's those two. And then if you want, you can try to make them pretty and stuff like that. You can, do whatever you want to do. However you want to do it. I usually just kind of get them out of the way at first, because you're going to always have to move these things around to make things pretty. All right. Click. We're going to put that there. I'm showing you as if we are flowing through the amplifier right now. So we're following the schematic as if we're just kind of making a walk through our amplifier, and this is the easiest way to kind of visualize how your layout will go. So now we're into our first stage volume pot. So our volume pot needs to go to something that's going to get us onto the grid of the next tube. So let's go ahead and just lay those parts out. So let's get this in the right mode and select some resistors. So we're going to say that this is our grid stopper resistor here. And then we're gonna kind of do it in the same flow as this one, except for we're going to put our grid stopper here first. And then we're going to, not there, excuse me. We want our bypass cap next. And then we're going to put the resistor for our bias. So this is our bias resistor. So these two here, again, are part of the cathode. And then we know that we have a coupling cap. All right. And now we're starting to get into the phase inverter side of a cathodiene phase inverter, which is a bit different than our long tail pair. So I'm going to stop right here because it's going to start getting a little weird. So let's kind of wire this stuff in while we're here. All right, we're going to go to the right mode first. Click, escape out of that, and then we're going to go to here. Click, there we go. Now we need another one that goes from here down to our grid. So we're going to click, and then we know we got one that's going to go to our cathode. So let's go ahead and do that, and then we got one here that's going to go to our anode. All right, now these may not be in the right order to actually make this work, but I'm going to just kind of show you why you're going to have to try to figure this out a bit. So we know that this goes to our anode. So let's go ahead and clean that up a little bit. All right. And then this is going to go to our cathode, which is that guy there. So you can kind of see already that it would probably be smarter for us to put the cathode side of things over here first. So we can see now that the grid is in the middle, so it's probably wisest to put that there. So here's what we're going to do. We're just going to do this. Since we already have our resistor there, we're just going to do that, right? And what do you know? It kind of lines up really well with the center of our pot up there. That's pretty cool, actually. And then let's take this guy, and let's move it over one, and then move it up one. So this is going to just go to our grid and get out of the way for us. And then this guy here, let's just put it there because it's already nice and tidy. And then that's going to go to our cathode. So do something like that and something like that. Very pretty, not too bad, right? All right, sweet. We need to jump these two together here. There we go. I didn't jump very well, but whatever. All right. I guess, hold on. I'm going to undo that. It would probably be better if I just did this. All right, so we still want the jumper, and that'll make it much straighter. I like straight. I'm weird like that. All right. So we've got another whole stage kind of done here. We also need to jump this end together here. Excuse me, that was wrong. Hold on. I was doing it the old way, not the new way. Blip and blip. There we go. Now we got some other stuff that we need to connect in here in a minute, but I'm going to wait on that in just a second here because this is technically our ground at the moment, all right? So let's just we'll come back to that. So this is now let's get that out of here. This is now our coupling cap. So this is what's going to go into the next stage or the grid of our next tube. But we got a cathode that's kind of in the way. So do we want to keep going the way we had on this? Let's try it and see what we get. So we know we're going to need a resistor, and we need a few of them. So let's say that this is our primary one here. Let's say that this is our bias resistor. And then let's say that this is our tail resistor, all right? And then we need another one that goes to the actual grid. I'm going to add the grid stopper resistor in here, just so that way you can kind of see how it would actually be built. Now, if you recall, again, if you didn't watch it, go back, you'll see I did not include the grid stopper resistor that I was talking about in the schematic. But this isn't the schematic right now. I'm trying to do it as if we're going to build it. And I said I was going to add a grid stopper in there. So that's kind of important to make sure that that is there. All right. So the way this is going to work, and I'm going to try to do this off of memory, so forgive me if I didn't quite get it, but let's, I know that it's going to come off of here, and then this guy is going to touch at least two of these guys. So I'm pretty certain that it's going to be something like this. And you're probably looking at me like, what? So we're going to pretend that this is our grid stopper here. All right. And that this one here is going to go to the center of our network of resistors. So we're actually needing one more resistor here. Let's go ahead and pull that one out. All right. So, this is our grid stopper. Do we want it to be our grid stopper? I kind of want this one to be our grid stopper. Let's make that one our grid stopper. let's see if I can make this work. I'm trying to do this out of my head from memory, so please do forgive me. This is real time. Do be mindful. All right, so we come out of this guy here. One of these is going to go away. I just don't know which one yet. So we're going to come out of here. This one here is going to go to the center of our network. So this one needs to go away as well. So this is our 1 meg, right? And our 1 meg goes to the middle of the other two. But we want one of them to be a 56K. So I'm going to say that this one is our 56. So this one is going to go to ground. And then this one is going to go to our 1.5K. So let's make a jumper that goes to here. So this is our 1.5K. So this is the one that actually touches our cathode. All right. So let's go ahead and wire that in. So escape. When I say cathode, I literally mean our cathode here. Oh, I got it in the wrong mode. Hold on. Please, thank you. All right. So I may need to adjust this a little bit, but you can kind of see where the challenge of this comes in from when you're trying to do this. It's not just slam it out there and go. It's not that easy. And then I think this one needs to come like something like that, right? All right. So here's our 1.5K. This would be our 56K. And then this one here is going to be our grid. And then this one is going to be our 1 meg grid leak, I guess you would call it. And the grid leak goes to the middle of those two. So I need another jumper that goes like this. You can kind of see how ugly this is getting right now. And then this one here will connect to that like that, okay? So you can kind of see how it gets really weird underneath these boards. And we've done pretty good so far. We don't have a lot of stuff crisscrossing everywhere yet. But we do have one crisscross that's going to happen here. And I suppose if you want to get crafty, we could go the other way with that. Ooh, how could we pull that off? We'll have to come back to that. I'm not going to try to spend all the time trying to figure it out. So I'm just trying to pinpoint here why you're going to come back to this several times to try to figure this out before you actually get it. So there we go. So there's our first little crisscross that we have, but not too bad, right? Not too bad. All right, then we got our anode side of things. So our cathode, we need 2 of these guys here. And then our anode. So that's going to go there. Ooh, you know what we forgot? We forgot a plate resistor. We're going to need a plate resistor in there somewhere too. That's going to make things interesting. All right, so we've found our first mistake. Oh, darn. So our cathode, or our plate resistor, excuse me, is going to come for this guy here. And we need it to be somewhere in here, right? So that means we're going to have to put in, I'm going to have to decide somewhere, but I know it's going to go, let's just put it right here. Let's say we're going to put it right here, and I'll show you what I mean. All right, so this is going to play as our plate resistor. So let's just say that's where you wanted to put it, but that thing needs to run and power something all the way over here, which means you got a choice. You can either run a hot wire that goes all the way over there to get to this part that's right next to that one, or you can just run that wire all the way over there. So we're just going to run that wire all the way over there, because either way you're running a wire over there. It doesn't matter how you try to do this. You're running a wire over there, period. So this is going to be our plate resistor, and I'm going to put it up in here like this. Oh, make sure that you collect what you're trying to collect, because if not, it's going to get really weird. So you can see now we're already starting to crisscross some things here. Now again, this is under the board. So what I'm going to do is color this red. So we're going to go edit selection, and we're going to change it from that to that. And this is just so we know that that is a red wire. This is our plate resistor. All right, so now these are our cathodes and our plate for the second stage. So let's do the wiring for that. Now I'm going to stop pretty much right here, because you'll probably get the idea at this point. And let's see here. This one is actually going to go to the cathode, so I probably don't need to have it go here with a wire. Because yeah, no, I don't need that. So we're just going to delete it. This is going to go to that. All right. Oh, get out of here. All right, so there we go. Now, you can move these around to try to make things as simple as you can, and it's a little bit easier to see now that it's in this orientation here, right? You can basically move this resistor over or something like that and change how these wires jump to make it so that these wires here don't have to crisscross. And I would obviously suggest that you do that because it really doesn't matter at this point where all they go. But you want to try to make it as clean as you can, right? And then this guy right here comes hot off the cathode. So hot off the cathode means this one right here. So we need to have a jumper that goes from here to there. So you can kind of see how there's all kinds of different ways that you can do this, but none of them are going to work really well when you're trying to do it like this. And when I say like this, is what I mean is like the high watt style, right? And I don't want, yeah, that's the one I want. All right. So high watt style is, like I said before, is fraught with kind of its little quirks, if not issues. So that's going to go there. So all these wires down here are going to crisscross in some way or another. But on the top, you don't really see it off the top, right? You change this orientation around a little bit, and nobody's none the wiser, but it still can be an issue. But there's all kinds of little jumpers underneath. So let's stop right there, and well, we'll do one more. We'll do one more part. So here's that. And then we need to change the size. So we're going to go to... And another thing I forgot to put in there was the dropping resistor. So I do need to add another resistor in here somewhere for the dropping resistor. But let's do this instead. I'm going to escape out of this. And if you wouldn't mind, I don't want that anymore. All right. So let's do this. And I need to be in the right freaking mode. All right. I don't know. I feel I did pretty good trying to literally go from memory. So, you can hate all you want, but don't hate the player, hate the game. So I'm going off of memory. And if you are sitting here looking at me going like, what the hell are you doing? And you have not a clue, then go and find like a 5E3 schematic or go back to that other video I had and set this side by side, and it'll make a lot more sense in a minute. But for now, we're going to take this guy and we're going to move it a little bit because I have an idea here how I'm going to do this. So we need to have a dropping resistor for each of these stages. And what I want to do is make this thing 1.5 inches, or 1.49 actually, by 0.73. Okay, so now that's how big that is. So we need to create a dropping resistor now for this network here. So this is our plate resistor. So that's going to have our jumper that goes from here to there. And then we are going to have our dropping resistor. So we're going to take this guy and we're going to put it from here to here. And the way we're going to do this is create a jumper that goes from here to here. And then we're going to jump another line that goes from here, escape, and then goes over to here. So again, you can kind of see how it gets a little ugly underneath the bottom side of these boards. Somehow or another, this thing has to get over there. And it doesn't matter if you run this wire on the bottom or the top at this point. One way or another, you're jumping over to this side and back down to the other side. So even if you were to get this resistor here, over here, a wire still has to go all the way across over to that point to get it down over there, which means one way or another, you're crisscrossing this board, you're transversing this board. So you can kind of see some of the pitfalls to this type of layout style here, but it is a little bit easier to see and it's a little bit cleaner to look at, especially when, like if you were to send all these, when all you can see is the parts on the top, right? So you don't see all these little jumpers in there, all these little ugly things that make it look ugly. You don't see those. All right, I'm going to stop there kind of. We need to just do some other little jumpers here for the grounds. So let's do that. Let's kind of get our grounds snatched up here a little bit. So we know we need something there. This is another ground here. This is a ground here. No, this is the ground because this is our tail. And this is a ground. I don't know exactly where that one's going to go yet. I may have more out than I need. Well, let's find out. All right, so this is going to go to that. So this is our first stage ground there. All right. So imagine this is all still underneath the board, and I'm going to get out of this mode. It's a real show now. I'm sorry, that was kind of rude and crude, but it's turned into a thing. It's not a show until you get burped upon, right? Got to make it interesting somehow. All right, so what I'm doing here is cascading all of my grounds, okay? That's all we're doing is just cascading the grounds at this point. So let's get that one kind of there. And then obviously this one here will need to continue on to that point as well. So again, just imagine all of these wires kind of hanging out underneath your board. And they're going to get all snatched up in there. And it's going to look all ugly and stuff underneath there. But on the top, it looks all kinds of cool and pretty. All techy and stuff, right? And then, of course, there'd be still more down this way, because we still have some other stuff. Let's get some of this other stuff kind of wired in here. So, let's see here. I may not have done this quite right, because I do... Well, how am I doing this? No, I did it right. So these two here are our, whatchamacallits. So this is our cathode, and this is our anode off the phase inverter side of things. So these, I'm using a post-phase master volume on this amp, right? So I need to run both of these to the dual gang potentiometer that would exist there. So what you're about to see is not going to make much sense when you're looking at it as it is right now, because you're going to just see two wires go to the same thing, right? Let's see if I can get it to do what I want it to do. That's probably good enough, to be honest. And if you don't mind, thank you. So they're both going to go to the same spot, if you will, even though they're different wires. Let's go ahead and do ourselves a favor, and I'm going to select all these. I pray and I hope. Oh, I did it. Oh, I get lucky. It's really a fine line. If you miss, you can really mess things up. And then you have to hit Control-Z and undo all the work you just did. So there we go. So we got that. And I usually just leave the signal wires green just because it's easier for me to tell what's going on. All right, so we got this. This is our master volume here. And then this would obviously go out to our power tubes, right? So we're not going to bother with that circuit because we're already kind of getting long here right now. We don't need to deal with it. You got the idea. That's all we want is the idea. I think I've showed you most of the pitfalls to this thing. So, all right. So we're going to pretend that those go out, and then this is ground. So let's go ahead and get our grounds kind of done up here. So we got two more of those to do. And we want these to kind of ground at their respective spots. So that's the cathode for this tube. So we want it to ground there at its cathode. And actually, it would probably go over here realistically, but that is fine right there. And then this one technically has to cross over, unfortunately, to work out here. So what we're going to do is go chink and go black. Sometimes, come on, there we go, thank you. And this one do the same. And I just do this so it's a little bit clearer what is what. I only use like 2 or 3 colors of wires in my builds. I do black as ground, right? It's probably not the correct way to do it because technically black is generally like line or hot, but I use red for hot, so I kind of run it as if it were a battery or like a DC circuit. And since this is technically a DC circuit, that's the way I kind of do it. So, and then I make all the other wires white. So all these wires here I would do as white, but you can't see white very well in here, so I leave them as green. And then all the ground wires, of course, are black, etc., etc. So it looks essentially like this. Just imagine all the wires are being, as white. And then I use red and black for the heater wires just because I like the contrast of red and black, and it just helps you keep the orientation correct. More or less, if you put black on the heaters here and red on the center tap on the next, tube, you want to make sure you put black on the heaters and red on the center tap. All right, makes sense? And the center tap is pin 9, by the way, and it is literally the center tap for these guys. So when we're running it like that, we're running them in parallel, I believe. And when you run them in parallel, or is it series? No, it's running them in parallel, but when you do that, it you know, you use less voltage, but you burn more current. All right, makes sense. And then I guess since we have this pot hanging out here, we may as well. Oh, we got one more wire to change the color of. Sorry, a little OCD action here. Thank you. All right, and let's go ahead and do our tone control. So the tone control works kind of like this. So that'll go in between there. And we're going to escape out of this. And then there's another wire that goes from here and goes to the in. Oh, see what happens if you miss it? If you miss it by that much, you're boned. And then you end up having to go Control Z to undo it. That much. Like, it's got to be perfect. You got to be perfect. All right. And I'll just go ahead and do it this way because why not? I missed it. And I'm never going to get it again. All right, never mind. So there you go. Now you got it. All right, so let's zoom in one more there. There you go. You can kind of see what we've done here. Now, this is a way of doing it. It is not the way to do this. So this is, like I said, where your character and personality is going to kind of come out, right? Because there are all kinds of different orientations to do this. You can do it, you know, where the style where you put all of these large capacitors on a board over here off to the left or something like that. They exist over here. And then you just run jumpers over to this turret board or off of cap cans or something like that if you're into cap cans. I don't like cap cans. And then, you know, you have to run wires to your plate resistors and your dropping resistors and stuff like that, right? Actually, no, the dropping resistors usually exist on the board with the decoupling caps, but you still got to put the plate resistors and stuff like that in there. So little things like that are obviously a thing. So there's all kinds of different orientations for this. This is probably the best orientation for this side over here. I don't know that you can, you know, do any better with that, short of taking this guy and instead of jumping it across, you do something like that, which you could do. But that's up to you. There's all kinds of different ways you can do this, and you know, it's literally up to your imagination. So let's stop with this for a moment and look at what I have decided up to this point in time of what I am going to do with my build. As you can see, completely different, and I'm still not settled on this layout yet. But you'll notice one thing that is that I work very hard to do, which is to make sure that all of my HT stuff, all of my high voltage, never breaches the middle of my board, which is to say that even my decoupling or my dropping resistors and my plate resistors and stuff like that do not breach the middle of the board. And in this case, I've done pretty good. I literally have this wire just kind of down here the whole way. All right? So I did good in that regard, I think. The downer to it is that you end up with situations like this where you end up having to crisscross, you know, a grid wire around or near a, you know, HT resistor or HT wire or something like that. Again, obtuse angles, so right angles or as close to right angles as you can get. The chances of it actually interacting is very, very little. Remember, the more space that you have, the better off you are. I think for every 1/8 inch of space you create, you like have the amount of noise potential that, you know, can be induced within each other. So in something like this, where you get the wire down against the turret board, this thing's raised up almost 3/8 of an inch. So you've essentially cut out any kind of induction that you can possibly get anyway. And then if you use really high quality resistors that have very low induction properties to them anyway, it won't induct as much anyway. So there's all kinds of different ways, and do not copy this because it is not settled. This is an unproven layout right here at the moment. A. B is that I'm not even certain this is how I'm going to do it. This is just where I'm at currently with my idea. And of course, I got the whole string on here. So you can see here, I got my first, you know, reservoir cap here, my first dropping resistor there. This is the screen grid resistor, if you will. And then we got our second node for the screen grid itself. I didn't show, but I'm probably going to put a screen grid resistor in here as well. I just haven't decided if I'm going to use 1 or 2 yet. We'll get there. I have my first dropping node here for this guy here, and I left it out of this area here so that the grids going to the power tubes are left alone. I tried to leave as much space as I could here. This is the bias resistor for the power tubes, and of course the bypass cap for that. These are our grid leaks here, and you can kind of see here, this is our dual gang master volume pot here. So you see our 2 wires going into those and the 2 wires going into those, right? I try to do what I can to make all of these wires kind of lay out nice so they spider into it. This is not probably the best way to do it, but it is a way to do it. I found another way the other day that I might experiment with, and then you can just see the run that I did for the grounding bus on the backside. So obviously this is just a way to do it, right? And then I got all the parts and stuff wired in. There you have it. So that's what I'm going to do with this one. So what did we learn? Let's kind of try to solidify a few things here. First and foremost, it's going to take you a little while to just wrap your head around this software. You can go through and label all of these, and you probably should. Right now, they're just labeled kind of C1, R2. You know, it lays it out in the order in which you place them. So, excuse me. Goodness. There's that. Obviously, you can see here that there are ways to do this that are simple, or you can make it more complicated for yourself by doing it like this. Obviously, to do something more like this, you kind of have to understand your circuitry a little bit more, which makes something like this just a little bit easier. I literally did this off of memory. I did not have to refer back to anything. So you can do it. And again, I mentioned it before. If you can do the schematic, you can build an amp, because if you can remember how to do the schematic, you can almost literally just map it out. Again, it may not be the best way to do it one-to-one like this, but then you can start getting into stuff like this here, where you end up having to be a little more clever and split things up. I do have a couple jumpers in there doing, over the top of each other. I'm not super duper happy about that. And I'm not super happy about this area here, but it might not be incidental. It may not be of any issue at all for me. So I don't know. I will work that out, and that will be my burden to bear. So, and then just general rules, I mentioned them in the beginning, is that you want to try to minimize the length of the wire. So you don't want to make this thing have to jump all the way across. As you can see here, I think I've managed to minimize the length of the wire pretty good, especially for the HT side, which is the most problematic, I think. The way I do it with the layout like this is that the heater wire, which is the noisiest thing in the whole of the amp, literally just shoots kind of down the middle of the whole thing. It's in and out, it's done, right? And then everything else kind of crabs over the top of it. Keep in mind that these are going to come off the top of the turret board here and then shoot down. We're looking down from the top, so there will actually be a little bit of an arc, kind of like this, in it. So these will be lifted up off of the turret, or off the tube things, quite a bit. So noise from the heater supply, I don't generally have a problem with, especially just because of the way I do it. All the ground stuff, all my ground plane stuff is on this end of the board here. And then all the noisy stuff is over here, and I did a really good job. It does not even breach the second row of turrets in this amp. All right, so little things like that you try to do, and then minimize the amount of crisscrossing of wires that you can have. I only have one wire in here right now that crisscrosses, and it's probably non-incidental. Mainly because it's in the phase inverter side of things, and in the phase inverter you get CMR, so with CMR noise tends to cancel out anyway, and at that point in the state in the game, there's not a whole heck of a lot to introduce noise into each other anyway. The only other things that are kind of a crissy-crossy are like these two guys here, but again, non-incidental. This is our cathode here, so this is going to ground anyway, so any noise that gets on here is likely going to be shunted off to ground anyway. So the only thing that's really in any danger of noise in this circuit right now is this guy right here. And it's debatable because there would be some air gap between this resistor and that wire, because the wire I could get down on the board, and then I'd have, at least a good, quarter of an inch maybe or more of space between it and that wire. But something to consider. I don't particularly care for it like that, and I may change that. So little things, always little things. Now, you said, Luke, why didn't you just put this all on this one thing here and get it so it has no opportunity to really come across it like that? I thought about that, and I'm really trying to make it so this is modular enough that this component here, if I need to change it, I can change it, and it doesn't, affect two other items that it connects to. So when you start doing things like this, let's say you take this resistor out, it's really kind of a pain in the butt to put it back in after you've already soldered it in. So replacing this, I'm just thinking down the future how I want to lay this out to make it so it's easy to repair for things that I think are probably most likely to be repaired, or still make it so it's easy enough. Trying to fit three lugs down in there is not easy, not fun, right? So thinking ahead in the future, of course, as well. So I try to do 1-to-1 if I can. If I can't, I try not to get it, I try not to put multiples of parts in there that aren't going to get replaced with each other anyway. Okay? So generally, by the time you got to touch this guy here, you're already taking this guy out, right? This guy is more than likely the only thing in this amp that's going to have to be replaced, which is all these decoupling caps, right? So taking this guy out, you're going to have to futz with this one anyway, so whatever, big BFD, right? So those are kind of the rules, and I think I did pretty good. Everything's pretty tight, pretty short, right? Everything's kind of snatched up. I love that word today. I don't know. The word of the day is snatched. All right? Anyway, let's call it here. I'm going to go back to here, if you wouldn't mind. Thank you. All right. Back to camera mode where we get to see my wonderful hands. Yay! All right. I want to thank you for sticking with me this far in the game. If you have, this is kind of a long video. It's about an hour or so. So none of this is going to be quick. I tell you right now, none of these videos in this series are going to be short. I will probably have a couple here and there that are shorter, but it's just the name of the game. This is real time, more or less. I can tell you right now, doing what we just did, you're going to spend a week or more maybe trying to just dial it in, unless you just go the not hack mode, but you know what I mean? Like if you just straight up, I'm going 1-to-1, we're just going to make it look like a high watt and be done with it. Sure, if you do it that way, it'll be done really quick and it'll look like a high watt, of course. But again, trying to reduce those potential pitfalls and issues is the thing. So there is that as well. Aside from that, the next stage, once you actually have decided on that, is getting all your parts. So I have some parts here. Trying these guys again. So I've got a couple of these that I'm going to use. These are those Vichy metal films here. These are going to be used for my power, for the power rail. And then, of course, I got my turret board. So the next step after this is to start populating the board and, getting all of these things kind of put in there and stuff like that. It's unfortunately the next video, I should say, on this amp is going to be probably another week or two out at least. I have another gig this weekend and I have another gig the following weekend that I have to do. And I'm going to try to retire a little bit more from sound. I keep getting pulled in. So I ended up getting sucked into a gig this weekend, which is going to completely halt anything I had going on up until this point. And I got another gig next week that won't really slow me up that much. It's on a Friday night, so it won't really affect me too much. But I'm still waiting on some parts to come in. I still have a couple more things. I am waiting for the chassis. The chassis is obviously very important, and it has not yet shipped. So that is obviously a huge thing that I will need. I can build the turret board, and that will probably be its own little video. And then we'll have another video where we kind of show the drilling and, making of the actual chassis itself and then populating some of the stuff into it. So I expect this video series to be probably at least 5, if not 6 to 8 videos in length. And we still have to work out the giveaway / raffle portion of it. I mentioned it in the last video that I'm leaning kind of towards the raffle aspect of it. I was talking with the wife, and she's like, why would you give to an organization that already has plenty? Why don't you give to something local or something like that? And I was like, well, people don't care about my local stuff. So I'm still leaning towards the raffle, mainly because it does provide opportunity beyond what we're doing here, which means I can then give back more. And I want to give back more. That's the big goal here. So I kind of think what I'm going to do is, instead of me giving the money away to charity myself, the winner, whoever wins the amp, can decide what charitable organization they want it to go to. No, it cannot be yourself. If you have something in mind, like a GoFundMe account that you have in mind or something like that, maybe your neighbor had something tragic happen and you want to help them out or something like that. Something like that. Well, again, we're going to deal this out later on. Do not hold me to anything yet. These are just spitballs at the moment while I try to navigate through how I'm going to do this. And if I don't do that, then I'm just going to do a straight up giveaway, and somebody's going to get something that could be valued at potentially $3 or $4 grand worth of work and effort and time and quality. And I think you'll agree by the time we're done that we are nothing short of that level of quality, and the value should be there, and I hope that you agree. Now, of course, the idea with this whole series is for you to learn how to do it yourself, not necessarily take my schematics and stuff, but you learn how to do it yourself so you can build your own $3,000 or $4,000 amp for about, I'd say $800 to $1,000 worth of raw parts. This one's a little bit pricey because I did order some other things that I know I'm probably not going to use, but I think right now, after I tally it all up, we're about $700-800 deep in it. And we haven't built the shell yet, but the shell you can buy from someone else online, or you can make it yourself. If you make it yourself, it'll be cheaper. It's just going to take longer. And I don't know what your craft skills are. That might change the game a little bit. So enough of me jibby jabbing. I want to thank you for sticking with me this long. And cheers, and we'll see you in the next one. So take care. Bye.